Hey everyone, welcome back. We have our 7.5 notes today, and we're finishing up our unit on our quadrilaterals, and we are doing properties of trapezoids and kites. So let's talk about definitions here. We have quite a few we need to go over. So let's look at trapezoid. A trapezoid is a quadrilateral, so a four-sided shape with at least one pair of parallel sides. So I'm going to draw a picture here in a second after we do some of this. Um, Bases, these are the parallel sides of a trapezoid. Base angles are, well, all of the angles really are called in a trapezoid, but the official definition is still a little longer, so bear with me, is either pair of consecutive angles whose common side is a base of a trapezoid. Then we have the legs of a trapezoid. And I'm going to draw a picture here. So legs are the non-parallel sides of a trapezoid. All right, so the non-parallel sides of a trapezoid. I'm going to draw a trapezoid here. So we're going to have two pairs of parallel sides, which means if we look here for this to be a trapezoid, we're going to have two sides that are parallel. That means these are called our bases. So we have a base, we have another base. These two parts right here that I'm doing in blue are called the legs. And then we have these green parts. These are the base angles. And so are the other two. All right, so they're called base angles. All right, so now that we have the parts of a trapezoid known, so we have the bases, we have the base angles, and we have the legs. Let's talk about a specific type of trapezoid. So we have an isosceles trapezoid here. An isosceles trapezoid is a trapezoid that has congruent legs. So here's my trapezoid, and I'm gonna try to make this look a little more congruent here. That just means we have our two bases are parallel and our two sides are congruent. So that would be an isosceles trapezoid. And then the mid segment of a trapezoid is like the mid segment of a triangle. This is a segment connecting the midpoints of both legs. So a quick little picture here. Draw a trapezoid. Try to make this a little cleaner. Sorry. There we go. Let's find that midpoint on both sides. So I'm going to have a midpoint here, midpoint here. I'm going to connect these. Because they're midpoints, we have some congruent sections over on the sides. That would be a mid-segment of a trapezoid. All right, last but not least is kite. It's our other shape today in this notes. This is quite a long definition, so I'm going to try to abbreviate some words. This is a quadrilateral, so a four-sided shape that has two pairs of consecutive, congruent sides, but where the opposite sides are not congruent. So some abbreviations there, some symbols there. So let me draw a picture of a kite here. So here's my kite. These two sides here are going to be congruent. Then I'm going to connect these two. Oops, I don't want to use that color. Let's use this one. These two sides are now congruent. So they're consecutive, but notice the sides that are opposite of each other. So let me make this a little easier with my arrow here. So we have two consecutive ones. You can see with this big arrow here. And we have two consecutive ones that are congruent with this arrow. But notice the sides are opposite. So my blue double tick mark and my red single tick mark, they are not congruent. All right, so opposite sides are not congruent, whereas like in your parallelograms, they are. So we have trapezoids and kites today. Now, it's already been a pretty long part of our notes. Now let's get into actually the theorems. So again, a lot of stuff. So all these theorems are talking about specific things. So here, these first couple are talking about trapezoid, and specifically, we have a converse and a regular, so these are related. So the first theorem here says, if a trapezoid is isosceles, then each pair of base angles is congruent. All right, so there's a property, isosceles trapezoid, base angles are congruent. Now each pair, so notice here we have angle A and D are congruent, then angle B and C are congruent. Then you have the converse. It says if a trapezoid has a pair of congruent base angles, then you have an isosceles trapezoid. So if you see the base angles are congruent, we can prove that we have a trapezoid based on the converse. Next page, here we go. Isosceles trapezoid diagonals theorem. A trapezoid is isosceles if and only if, so this is biconditional, the diagonals are congruent, the whole thing. So BD and CA are the same measurement. So if they're congruent, we have an isosceles triangle, and because it's biconditional, that means if the diagonals of a trapezoid are congruent, then we have an isosceles triangle. Mid-segment theorem. The mid-segment theorem basically says that it's going to be parallel. So right now it says the mid-segment of a trapezoid is parallel to each base. So that's the first part. So that is just something to know that it is parallel. And here's the kicker. Its length is half the sum of the two bases. So if you add the measurement of AB, add the measurement of CD, it's going to be half of that. So there's our first formula. Next theorem. Oh, the next two are the two with kites. So a kite diagonal theorem says if a quadrilateral is a kite, then its diagonals are perpendicular. Then we have if a quadrilateral is a kite, then exactly one pair of opposite angles are congruent. Remember, it says exactly one pair are congruent. Okay, so angles C and A here are the congruent ones. Okay, now that we've had almost 10 minutes of vocab and theorems, let's actually get into using this stuff. Again, it's a longer thing of notes. All right, number one, show the quadrilateral with the vertices, and we're going to show that it is a trapezoid. Then we decide if it's isosceles, and then we want to find the length of the mid-segment and trapezoid. So this is a big thing. So let's go ahead and make a lovely graph here. So let's go ahead and put an X and Y axis on here. For this to work, we need to let's go over just a little bit. Let's put our y-axis here, just slightly over, and then let's put our x-axis down one more normal than we usually have. So there's our y and our x-axis. Let's go ahead and plot these points. We have 0, 3, and that is our Q. We have 0, 6, that is our R. And then we have negative 6, 0, that is S. And then we have negative 3, 0 is T. So we are going to connect these. There we go. Now, for stuff to see here, we want to, it's first asking, decide whether the trapezoid is, well, it says show that it's a trapezoid. So showing that it's a trapezoid means we have the bases are going to be parallel to each other. So that means look for the slope. So to show a trapezoid, show parallel lines. So the slope of SR is up 1 over 1, up 1 over 1. So that slope is 1. And then if we look at T to Q, this slope is also equal to 1. So the two slopes being the same show that we have parallel bases, so it makes a trapezoid. Check. All right, next part. Decide whether the trapezoid is isosceles. So if you go back to isosceles, we know that with an isosceles trapezoid, we have the if and only if that says the diagonals are congruent, and then we also have the fact that the base angles are the same, but if you go back to the definition, it says congruent legs, the same. It just so happens I can find RQ by just counting here. RQ is worth 3. And then if I look at ST, which is the other leg, that is also 3. So because those are congruent, so RQ is congruent to ST, that shows this is an isosceles triangle. Check. Find the length of the mid-segment. So the mid-segment means I am going to take my two bases, add them together, their distances, and multiply it by 1/2. So here's the formula. I'm going to take 1/2, and I want to find SR, and I'm going to add TQ. Now that means to find SR and to find TQ, we're going to have to use our distance formula. So SR is equal to, if we look at our points here, we're going to do our distance formula. All right, so the difference between our x's plus the difference between our y's, all that squared. So x is for S, so I'm going to get negative 6. And then for R would be 0, and then the y values would be 0 and 6. I'm going to get 36 plus 36, which is the square root of 72. And then the square root of 72 is about, I think, 8.5. Then we're going to get TQ. Again, square root. Let's go ahead and fill in our distance formula. So I'm running out of space here, running a little too big. And for TQ, we're going to have 0 and then negative 3, so that'll be a plus 3. And then for the y values, we can get 3 and 0. So 9 plus 9, this is going to equal the square root of 18, and that's roughly, what, 4.2? So this means I'm going to take 1/2 times 8.5 plus 4.2. Throw that in the calculator. I'm going to get that this is roughly 6.35 for that mid segment. Roughly, we did a little bit of rounding with our radicals there. Wow, that was a lot of stuff. All right, that takes care of all those parts. That's the craziest of them all. Let's keep going. Again, sorry, really long thing of notes. All right, let's look at this. We have a trapezoid here, and I also see congruent marks. So we see this is isosceles. So isosceles means base angles are the same. So if we have 23, that means the measure of angle L is also 23 degrees. And that says find the measure of angle K. So if we look at angle K here, we're going to know that it's going to be 180. And the reason why, I'm going to do 180. This is equal to 23 plus the measure of angle K, because with our parallel lines, this is a transversal and we have consecutive interior angles which are supplementary. So basically subtract 23 from 180 and you're going to get that the measure of angle K is going to equal 157 degrees. Number 3, here we have a four-sided shape. And notice that we have two pairs of consecutive sides that are congruent. So I have congruent sides here, congruent sides here. Now, remember, with it being a kite, notice J and M are not congruent, but that means one pair of angles has to be. So angle L and angle K have to be congruent as well. So what do we do? If we look at this, those are the same. So if we put like a little X here, because it is a four-sided shape, we know that total is 360, and that's equal to my two X's plus that 90-degree mark plus that 130 degrees. And when you solve, you're going to get that both angle L and angle K are worth 70 degrees. All right, let's go to number 4 and 5. So number 4 here, this is our mid segment because I can see some congruent marks here and they're all parallel. So it says find CD. So remember that means it's going to be 1/2 the two bases added together, which is 12 plus 36. Put that in the calculator, you get 24. Now for number 5 here, that 1.8, which is the mid segment, is from having half of one base plus the other. I'm going to put an X here just because I don't know what that is. And if I solve this, which I would actually solve this, I'm going to get X equals 3. But I'm going to fly through that just because of the length of the notes. And it looks like we have 2 last questions. Woo, hallelujah. Here we go. Wow, we have a mid segment here. So here's what we know. We know that if I take my X plus 11 plus my 3x plus 3 and cut that in half, I'm going to get 3x minus 2. Now notice what I did here. I didn't take the whole thing times 1/2, took the whole thing divided by 2 because now I can multiply both sides by 2. Next thing you know, I get 4x plus 14 equals 6x minus 4, and I'm going to get the x equals 9. All right, number 7, we have our kite here. Now, one thing we know about a kite is that its diagonals meet at a perpendicular. So what we know here is we have point G, which is equidistant H and F. If we go back to our converse of our perpendicular bisector theorem, it says basically go back to the perpendicular bisector theorem, make sure I don't say this incorrectly. Because these are equidistant from F and H, G lies on the perpendicular bisector. Right, so we know this is perpendicular, and because it lies on the perpendicular bisector, that means 9, or JH, is congruent to 1/10 x minus 1. So we're going to talk about using our perpendicular bisector theorem converse. Because of using that, we can say that 9 equals 1/10 x minus 1. And when we end up solving this, we're going to get the x equals 100. All right, there's your notes. Sorry they're so long, but best of luck. If you have any questions, reach out, or we'll see you in the next thing in notes or in class. Have a good day.